Okay, this is lab report two, lines of charge. So just to introduce this lab, so pretty much the main thing that happened is we removed an assumption in the lab one model in order to produce a more accurate representation of the charge tapes phenomenon. And so it was found that the electric force ended up differing from the gravitational force. And then another keynote is that charge used in this lab differs from the charge used in lab one, which is kind of what led to the different results. And then this is the new electric force magnitude. And so the purpose of this lab, revisiting lab one pretty much, the main change is that now the tape again is being modeled as having the charge evenly distributed along the length instead of it just being concentrated as a point charge. And then this lab is purely computational because it's just revisiting the coding portion of lab one. So this is the data from lab one. These are all the values. So mass, length, charge, and the two magnitudes. So this is again, these were both equal. And conditions assumptions. So they're pretty much all the same, except now tapes again modeled as lines of charge. And then just to reiterate, air resistance is not a factor in this lab. And then also it's assumed that at each point, the charge is the same along the length of the tape. So this is the code, this is the constant, and then again, this is just electric field. So going to kind of what's different, this line charge is different. It's actually a higher magnitude than what was used for the point charge. And then over here, this code is used to define the actual line of charge for the tape instead of just having the two spheres. And so going over to this part of the code, so this is top and bottom tape, and this is how they're both being modeled. It's using that function. And then the amount of times that the charge is being inputted in the code is 100 times. So it'll be 100 mini spheres pretty much in lines parallel to each other. And then over here, this is how the electric field is going to be modeled. And then down here is how the two forces are going to be modeled, electric force and gravitational force. So just going into the results from the code. So the green arrows is the electric field. Pointing down is the gravitational, pointing up is the electric force, and then these are the two tapes. And so pretty much the gravitational force is the same value, but now the magnitude of the electric force is actually lower than the magnitude of the gravitational force. And so kind of going into why that happened. So point charge was 9.5 times 10 to the negative 9 coulombs, but then for line charge, it was 1 times negative 8 coulombs, which is kind of why the data ended up being different, the model. And so kind of going into why. So the point charge is a concentrated charge upon its center, while line charge is along the length of the tape, which is a more accurate representation of what it is in reality. And in that case, electric force wouldn't equal gravitational force because eventually the tape is gonna go back to where it was. It's not gonna stay risen up from the electric force. Going into sources of error, so the line charge estimation is still not completely accurate because again there was 100 iterations. So it was a limited number and it's not infinite infinitely small pieces, which is kind of where you would see that in calculus. And so also in the actual experiment, it's likely that charge is not equally distributed on the tape since it was induced by a rubbing action, which could have not been, equally done along the length of the tape. And then air resistance may play a small role in the interaction, but it was in a closed environment, so that wasn't as big of a factor. And so just to conclude, so accuracy of models very depending upon the data you collect and how many assumptions you include. So models won't may never be 100% accurate, but as we lessen the assumptions and restrictions on the model, we'll get closer and closer to reality. Thank you for watching.